Hello everyone, and thank you very much for organizing these wonderful days about Wikidata modeling. So I'm gonna present a scientific approach we developed with some colleagues about reusing Wikidata to bootstrap a new knowledge graphs, and especially selecting some specific subparts that can be of interest to bootstrap a new knowledge graph. So this presentation is actually based on a paper we published recently. So I've just put the reference here in case of if you want to have more information, you can still read the full paper or just send me an email and I will be very glad to answer. So first, a bit of context. When building and fueling a knowledge graph, we have a virtuous loop of knowledge extraction where we can use some automatic knowledge extraction approaches from text or tables to detect new knowledge and enrich the knowledge graph. And this knowledge graph, in turn, provides terms and relations to the knowledge extraction approaches to focus on in texts and in tables. So this is a particular virtuous loop because when you enrich the knowledge graph, you have new terms and new relations to focus on and so on at each turn of the loop. However, the main problem arises when the knowledge graph is initially empty, when you are creating it from scratch. And so you don't have terms and relations to focus on in the knowledge extraction approaches. And this was the issue we wanted to address, how to bootstrap the knowledge graph when it is initially empty. So of course, we could use manual modeling to bootstrap a knowledge graph, but this is a tedious task, as we all know, error prone, and sometimes people have already model existing knowledge about what we are interested in. So of course, we may want to say we could reuse some existing knowledge in the semantic web, in Wikidata, in DBpedia, in very big and generic knowledge graphs that contain the knowledge about lots of aspects, lots of domains, and for example, the domains we are interested in. And so this is what we propose. We propose to use a generic knowledge graph such as Wikidata to bootstrap our new knowledge graph. So we could say maybe we're gonna consider the full Wikidata, but of course Wikidata is very big. It contains knowledge about lots of domains, and not everything is of interest. And if we integrate everything, we may have some noisy entities that we are not interested in, and we may have scalability issues of manipulating such a big artifact. And so we may want just to use some subsets of Wikidata, some subsets of interest. So let's assume you have some entities of interest, for example, a list of concepts from computer science you are interested in. You may want to browse the hierarchy of Wikidata to extract upward classes or downward classes over there. And we are not the first one to propose such an ideas. For example, other papers have mentioned the same kind of extraction approaches. Okay, so that's great, but still we have many entities in Wikidata, and sometimes we may have modeling issues or uninteresting entities with regard to our use case. So for example, if we consider the use case of extracting a knowledge graph focused on computer science concept and enterprise-related computer science concept, starting from Microsoft SharePoint, we may move to social software, and from them to dating app, which is of course unrelated here and not of interest to us. So we need somehow to prune irrelevant knowledge and just focus on the knowledge we are interested in for the new knowledge graph, which does not say that it is not interesting to have dating app in the ontology hierarchy, but it is not interesting in the use case. So we need a specific pruning approach, and some have been proposed dating back to 1996, but many of them are actually manual or not exactly of the extraction of a subgraph, and this is our case. Other approaches, for example, try to extract ontologies with roots and leaves, which is not the case here. We just want to extract subgraphs. And so that was our issue. And for that, we propose to use analogical reasoning. So just to summarize, what we propose is an approach that, given Wikidata and a list of CQIDs, is able to browse the hierarchy of these CQIDs and extract some subgraphs of interest to bootstrap a new KG. So we propose a new model and 2 data sets to evaluate that, which we were, to the best of our knowledge, the first one to propose. So not to go too deeply into detail, but just to give you an intuition of what is analogical reasoning, it's some kind of a fundamental reasoning ways of the human mind to reason by similarities and dissimilarities between entities. So for example, one analogy could be Paris is to France as Berlin is to Germany. And the underlying message is Paris is the capital of France and Berlin is the capital of Germany. So that's why this is a valid analogy. Another analogy could be the planets in the solar system are similar to the electrons in the model of an atom. We could even use more complicated analogical stuff. So for example, on pictures of myself and my colleague, here you have a picture in color, a picture in black and white. So you could expect the last element to be the same picture, but in black and white. So that is the analogical extrapolation, looking on similarities and dissimilarities to extrapolate new results. So you have several cognitive processes related to analogies, abstraction, inference, creativity. And you can have several tasks, which is to detect if 4 elements are in analogy, or if given 3 elements, you can predict the last one to build a valid analogy. And in our case, we will use the detection of analogy. So given 4 elements, is this a valid analogy? And we will build analogy to select specific subpart of a knowledge graph. So for example, starting from Microsoft SharePoint, we want to have a model that say, we have to keep social software, we have to keep file sharing software, but we want to prune dating app. And how we do that? Well, we build analogies where we have examples of seed entities and reached entities where we know the decision. And on the right part, seed entities and reached entities where we want to know which decision to apply, i.e. to keep or to prune the reached entity. And we use analogical inference. So if the quadruples is a valid analogy, we will keep the new reached entity. And if it's not a valid analogy, we will prune the reached entity because we will not apply the same decision. So given some example, we would have analogies like, is SharePoint and file sharing software the same as MPEG-4 and multimedia format? So if this is a valid analogy, we will apply the same decision on file sharing software as the one that was applied on multimedia format. So if we kept multimedia format from MPEG-4, we will keep file sharing software from SharePoint if the model detects this is a valid analogy. So we experimented a bit on the 2 data sets we built from Wikidata, and we compared with other machine learning models. And what we found out is that the analogy model is the best model to perform the task, and also the one involving the less parameters. So for example, we have 800 fewer parameters than some complex model like LSTM. So it's very efficient and very effective. And it's also able to generalize on entities that it has not seen during the training of the model. So it's a very good model to extract subgraphs of interest from Wikidata. So this is an interesting method and approach because we've just seen that we are able to bootstrap a new KG by selecting subgraphs from Wikidata. And with analogical pruning, we have good performance, a reduced number of parameters, and a good generalization capabilities. But this is a specific task. And what we want to do is maybe to try to apply it on other applications. So for example, try to detect modeling errors in the Wikidata hierarchy. Can we detect subclasses that should not be where they are in the Wikidata hierarchy, or maybe other more complex modeling errors using the same kind of approach. So that's why I wanted to propose this talk and just maybe to talk with you a bit about how we can apply this approach on other tasks that may interest the community. So that's it from my side, and thank you very much.
Thank you so much, Pierre. We just reached the 10 minutes, so maybe we have time for one question if anybody has anything they would like to ask from that talk. All right, seems pretty quiet. General question from Nicola. What do you plan to do next?
Okay, so thank you for the question. We are actually discussing with some members of the Wikidata community to work on the improving Wikidata class hierarchy. So in a remodeling use case that you may have that will be actually presented in some other session, can we use our approach to help remodeling and detect, for example, subclasses that were under the same class and that should not be there? And this is the next plan. And maybe it will work well. So from the preliminary results we got, it looks like it's working well. And we are looking forward to more results on that.
Amazing. Thank you.
Very
And we're
much.
going to leave it there for now. M. Alton, I believe that you are next.
Thank you very much.
Thank you, Pierre. Really appreciate that.
To share my screen. All right. Is my screen visible to everyone?
It looks good to me.
All right, that's great. So I am Menel van Alta, and I'm going to talk a bit about the research that I'm doing on Wikidata schema validation, like the Wikidata schema validator output improvements. So for my background, I am a master student data science and artificial intelligence at the TUE, the Eindhoven University of Technology. And I am doing my thesis project on improving the online checks validator that is available directly from Wikidata. My supervisors are George Fletcher and someone you may already have heard of, Catherine Thornton. She has spoken in the past at the Data Modeling Days, I think. So the online checks validator is very useful for adjusting data to schemas and checking whether actual articles conform to a schema that you've built. And I want to make it more useful for that. And the main thing that we identified needs to be done is it needs to be easier to use and to interpret the output. So yesterday, we already saw a bit about the checks validator when we had some sessions about checks itself and about schemas. But what those sessions kind of hid was that non-conformances look really bad in the current layout for the output. So my goal is to improve this layout so that it is easier for newer users who do not have a lot of experience to actually improve either a schema or an item based on this output, because this output is rather hard to interpret. And there I come to your input. Specifically, I want to do interviews with people with different amounts of experience with using the tool, perhaps somebody who has inputted in making the tool in the past. For that, I am now asking for people to sign up on my user talk page to give input and kind of additions I want to make, and then argue that my research is useful for to do. So on my user talk page, there is a heading where there is a number of different rules. And if you think I fill one of these rules, thank you, Nicholas. He just posted a link in the chat to here. If you think I fill one of these rules, or I am something else that will also be useful for you to talk to, and I have time sometime in the coming month or so to talk with you once or twice, then please list yourself in here. Now, if you want to know more about this, you can ask on my user talk page, and you can also send a mail to this email address. And that's basically what I wanted to ask for all of you. If there are any more questions about this, then feel free to ask them now.
Amazing. Thank you so much, Manoj. Are there any questions? Cool. Dario says, you mentioned it making it easier for newcomers and people with less experience. Are you planning to invite people some other way than through sign up on the user page?
I'm hoping that by making it easier to use the validator and some of the other things that were talked about last week, more wiki projects will start using schemas by themselves, and then they will mention the validator on their wiki project page. And because of that, and then like also yesterday there was talk about like making wiki projects more visible, and so through that chain, the validator should become a lot more visible to new users. So for Nikki, the rules refer mostly to the tool. So that is the checks simple online validator that we also saw yesterday. This is schema E98. I would not recommend it. It's a little overconstrained, maybe.
Yeah, and like Lydia was saying, it's really exciting to see some improvements coming up here. And Nicholas also said it's excited as well. I've seen a lot of people confused by schemas and don't know what to do with them. So hopefully this will help.
Yeah, I can see how this can be hard to use. I spent the first 2 weeks of my project just figuring out how to use this and then what you can actually do with this output. And that's not an experience I would wish on the average user, because if you aren't very motivated, I think it's hard to start using it.
Really, really appreciate the determination to get through those 2 weeks and make it easier for everyone else. Does anybody else have any questions? All right, well, maybe we can leave it there. Thank you so much for your talk, Manoj. And we can move over to Nikki. Thank you so much.
Hi, thanks. Let me just find my screen.
Thank you.
Can you hear me okay?
Can hear you perfect. Thank you.
Great. Thank you very much for inviting me. I've really found the talks I've managed to attend over the past couple of days interesting. So I'm going to talk about how we are integrating Obsidian and Wikidata, and that's part of the work that I do at the Royal Botanic Gardens in Kew in London. And I'm a senior researcher in biodiversity informatics. So that's a branch of science where we're trying to use the information that we can make digital from natural history collections and herbaria, and integrate that with data that's been published in literature and data that comes from fieldwork, so that we can understand species distributions and what threats they face. Obviously, my part of that work, working at a botanic garden, is very much on the botanical side. And one thing we see with our botanical researchers is they really need to depend on a really wide range of information resources to do their work. And navigating those resources when they've been made digital can be a bit of a challenge because they're scattered around. Around 20 years ago, we started making some experiments in what we then called e-taxonomy. So moving the practice of the science of naming, taxonomy, moving that work online. I would say that looking back now, the open science movement has made many more general advances in how we've moved the practice of science online. And we've got lots of tools that help us do things like citation management and collaborative working. The whole Wikidata movement is really been built around the fact that people can do such big collaborative projects online now. But when I talk to individual researchers about the tools that they need, it still can be a bit of a struggle to access and navigate the resources that they need to do their work. And they need really to be able to get those data in context. So here I can show people working with physical specimens. They need access to the digital world at the same time. About a year ago, I worked with an open science leadership development program called Open Life Sciences. And the exemplar project that I worked on there was to extend Obsidian, which is a note-taking system, which is based around a local copy of a folder of markdown files. So you're completely in control of the data model and the data that you create for your projects. And I tried to extend it for specimen research with the idea that you could get at relevant data in context. So I wrote some plugins for this software that allow you to get at specimens from specimen repositories, scientific names, things like taxonomies, how those names interrelate and how we recognize the species within them, profiles for institutions and researchers, and literature. And a user can link those data up together as they're writing their research work and cite specimens in new work. The real key thing there, though, is that they can get at that data in context. So as they're writing, they can get hold of the resources that they need to reference. And as we've been showing this to researchers and kind of understanding what they need, then we became aware of this this plugin for a browser called Entity Explosion, which again works in context. So as you're browsing the web, this plugin looks at the URL of the page that you've loaded, and it compares that URL with how IDs that are stored in Wikidata are formatted into URLs. And if it recognizes it, it takes the URL apart, uses the ID to do a property query, gets the entity back, and it shows you a panel with that entity as you're in context on the web. So you don't need to go off to Wikidata to do a lookup. You can do that immediately in context with the page that you're looking at, and you get this whole panel of IDs back. And that's really useful for researchers to be able to get at that data. So here I'm showing an author profile from one of the resources that we use in botany. That author ID is stored in a Wikidata entity, and the query that the browser plugin has run has brought all this data back for the user to work with. So I wanted to see if I could do the same kind of thing with Obsidian. And just this week, I released a very alpha version of a plugin that does this. So the canonical example with Wikidata, of course, is Douglas Adams. So here I've made a page in Obsidian. It's a markdown page. It's got structured front matter in YAML. And one of the structured front matter properties is Wikidata Entity ID. So I can load, I can call through the plugin and get all the entity details back and sit them in a sidebar. So the user's got access to Wikidata information as they're working in context in their writing environment. I've got a really quick demo that I should be able to play here. So this is just showing that I can do a search, and this is using the REST web API. So it's just doing a text search. So I'm searching for a genus of plants. I get a list of matches back. I can pick one, and it's loading the data then into the sidebar. Those links either stay within the sidebar or the external ones go out to Wikidata. And then at the bottom, there's a whole list of identifier links, but of course they are all external ones. So people have got access to a whole ton of resources through the data that's been mobilized through Wikidata. The next thing I can show is like if you were writing a part of your research and you wanted to put front matter mappings in, then in the YAML front matter you can put in a Wikidata entity ID, and you can tell the plugin to load Wikidata from that front matter. So you don't have to do a search there, it's just going to find the mapped entity. And the final one is maybe you don't know the Wikidata entity ID, you're just, as a botanist, you're writing some notes on species, and here we've mapped an identifier. So this is the system that we use to manage plant names in botany, which is IPNI plant name ID. And again, we can send that as we've mapped those properties into Wikidata, and we'll get that data being loaded in the sidebar too.
Are you able to get back on and speak, Nikki?
Yeah, sorry about that. I've not used Jitsi before, and I thought if I lost connection, I'd get a.
You're all good. Do you want to continue on from there?
Let me see. Okay, so I won't go through showing this demo again. I was just really saying that you can either directly do a search into Wikidata using this plugin, or you can map front matter properties to Wikidata properties, and then that mapping will load you something in the sidebar too. It works well with what a colleague has done, where he's taken a big open access work, or a biographical work on people that did collections in botany, and each of the pages there is a biographical reference for a collector, and obviously a lot of those people are historical figures, so they're well represented in Wikidata. So getting access to that data is possible too. I'll just end with a few pointers to where you can download the plugin repository and install it and so on. The people that worked on Entity Explosion, I'd really want to thank them. That was a really excellent piece of work, and this kind of working model of getting at Wikidata when you're working in context somewhere else, I think is a really powerful one. And yeah, that's pretty much me. Thanks for making me part of the event in the past couple of days, and I hope that tools like this are gonna drive more people towards editing Wikidata.
Thank you so much for your talk, Nikki. I think you've already got a few Obsidian converts in the chat. Everyone seems very, very, very excited. Cool. There is a couple of questions here. I believe Tuka says, does every tool have its own HTML visualization of an item?
Does every tool? Sorry.
Maybe it's a completely different question. I don't think. Tuka, do you want to explain that? Or speak to it?
Tuka posted in the chat, Nikki, how do you create the visual representation of the item for the sidebar?
All right, yeah, I should have explained a bit more about Obsidian. So it's an Electron app. You write plugins in TypeScript. So it's pretty. There's a lot of them available, and I followed an existing one to do that. But yeah, you're basically making an HTML representation of how you want it to display. I know that Obsidian isn't open source, and for some people that is an issue. The plugins are open source. I've always found the community very, very, very open to discussion about why they've made the decision not to be open source. But I know for some people that's a blocker. I would say that kind of note-taking environment is something that is taking off. So there are open source equivalents like Logseq, and it would not be a difficult thing to replicate that in that environment if complete open source is something that you want.
Are there any other questions that anyone has for Nikki? We also have like another 15 minutes as well. If anybody wants to ask any further questions from Pierre or Minot, I'll give you a couple of seconds if anybody wants to write anything. It looks like there are no further questions. Thank you so much for all of your talks, Nikki, Minot, and Pierre. They were super interesting. I mean, so varied as well. It's great to see what you're all working on. I think we'll wrap up. Everyone can get a little bit of extra time. And next up, we have a better way to enforce a data model, suggestions to autofix. That will be coming up in 11 minutes. What? No, 12 minutes. No, 22. Oh my God. Wow, you have so much time. 22 minutes. Great. Thank you so much. I'll see you all then. Bye-bye.